story of rockets begins in early China. Chinese inventors discovered gunpowder, a substance that could burn very rapidly and produce a large amount of hot gas. They noticed something interesting: when gunpowder burned inside a tube, the hot gases were forced out through an opening. As the gases move in one direction, they push the tube in opposite direction. This is an example of action and reaction, which is the basic principle behind rocket thrust. The Chinese later attached gunpowder filled tubes to arrows. When the gunpowder was ignited, the gases rush out and produce thrust, helping the arrow move forward. These devices became known as fire arrows. However, these early fire arrows were not modern rockets. They were mainly used as weapons and were relatively simple. But they demonstrated a very important principle. When gases are expelled rapidly in one direction, they can push an object in opposite direction. The simple idea eventually became the foundation of modern rocket thrust, and many centuries later helped humans to travel into space. Over the centuries, knowledge of gunpowder and rockets spread beyond China. Rockets like weapons were used in different parts of Asia, the Middle East, and Europe. At first, rockets were mainly used as weapons. They were not yet designed for space travel. But slowly, people began to understand that rockets could do much more than simply create explosions. Scientists began asking an important question: could a rocket work without pushing against the air? This question would become extremely important centuries later. In the 17th century, English scientist Isaac Newton developed his famous laws of motion. His third law of motion states, for every action there is an equal and opposite reaction. This principle helps to explain how a rocket moves. Imagine you are holding a balloon filled with air. When you release it, air rushes out in one direction, while the balloon moves in opposite direction. A rocket works using the same basic idea. Fuel burns inside the rocket and produces extremely hot gases. These gases are pushed out through a nozzle at very high speed. The gases move downward and the rocket is pushed upward. Newton's laws provide the scientific foundation for understanding rocket motion. For centuries, people dream about traveling beyond Earth. By the late 19th century, scientists began seriously studying whether rockets could actually travel into space. One of the most important innovators was an American scientist named Robert Hutchins Goddard. Robert Goddard believed that rockets could go far beyond the heights reached by traditional fireworks. He dreamed that one day rockets could even carry humans into space. But there was a major problem. Traditional rockets use solid fuel. That's why Goddard began experimenting with liquid fuels. Liquid fuel could be controlled and fed into a combustion chamber, allowing the rocket to produce powerful and continuous thrust. After years of experiment, Goddard achieved a historic breakthrough. On March 16, 1926, he launched the world's first successful liquid-fueled rocket near Auburn, Massachusetts. That rocket flew for only about 2 seconds and reached a height of around 12 meters. That may sound small, but it was a huge achievement. Goddard had demonstrated that liquid-fueled rocket could work. His work became an important step toward modern space travel. During World War II, German engineers developed the V-2 rocket. It was a powerful liquid-fueled rocket and became the world's first long-range guided ballistic missile. The V-2 demonstrated the enormous potential of modern rocket technology. After World War II, rocket scientists and engineers from Germany became involved in the American and Soviet space programs. Among them was Wernher von Braun, who later became an important figure in the American space program. Soon, the United States and the Soviet Union began competing in space exploration. Both countries wanted to develop rockets powerful enough to launch satellites and eventually humans into space. Then, in 1957, the Soviet Union achieved a historic milestone. They launched Sputnik 1 on October 4. After this movement, Sputnik 1 became the world's first artificial satellite. It traveled around Earth and sent radio signals back to the ground. For the first time in history, humans had successfully placed an artificial object into orbit around Earth. After this, their next major goal was to send humans into space. In 1961, Soviet astronomer Yuri Gagarin became the first human to travel into space. His spacecraft Vostok 1 was launched by a powerful rocket. This achievement proved that rockets could actually carry humans beyond Earth, not just be used for experiments or weapons. Then United States began working toward an even bigger goal, that is sending humans to the moon. NASA developed the Saturn V, one of the most powerful rockets ever successfully operated. The Saturn V was enormous. It stood about 111 meters tall and used multiple stages to produce the enormous amount of thrust needed to send astronauts toward the moon. Then came the historic Apollo 11 mission. On July 16, 1969, Saturn V launched Apollo 11 from Earth. 4 days later, astronauts Neil Armstrong and Buzz Aldrin landed on the moon. And Neil Armstrong became the first human to step onto the lunar surface. From early fire arrows to rockets that carried humans beyond Earth, this journey showed the power of human curiosity, and perhaps the next chapter of this journey will take us to Mars.